Good morning, good afternoon, or good evening, wherever you may be, and whether you're watching live or archived. And welcome to episode number 58 of the Nautel Transmission Talk Tuesday webinar series. Yes, my eyes did slide to the left. Hey, we've had a break, and I forgot what number it was. Hope everybody had a great holiday. It was a really good break here at Casa de Welton. A little bit of snow, a little bit of ice, and a whole lot of time off. All good things. Today, we're going to jump right back into it. I've got la creme de la creme, if you will. Like I said, my goal here is to find people smarter than me, and we'll pick a topic and talk about it. And I got two of the smartest today. In the order that you see them on the screen, we've got the Director of RF Engineering at Shively Labs, Mr. Sean Edwards. Sean, thanks for being here today.
Hello, and it's always a pleasure to be part of these, and looking forward to the discussion.
I think we'll have some fun. And last but not least, by any stretch, we've got the handsome and talented Mr. Gary Cavell, the president of Cavell, Mertz and Associates.
You've been drinking again.
We're not supposed to tell people about that sort of thing. Now, and it's funny because, of course, the title is After the Transmitter, What Comes Next, talking about the things further down the line. And somebody in the comments, and I'll leave their name out of it just for personal protection, but mentioned that after the transmitter, what comes next? Well, make sure the beer fridge is stocked. So, it's all about the priorities. So before we get rolling, we'll do the mandatory housekeeping stuff. Of course, this webinar, as with all Nautel webinars, does qualify for half of an SBE recertification credit under category I of the recertification schedule. So jot it down that you were here today under whatever spreadsheet, notepad, stone tablet that you keep those that data on, and you've got yourself one little step closer to your recertification. I double checked, mine runs out in 2023, so I've got a whole year to go. At some point, I probably should start keeping track. We do make these as interactive as we can. There's a little question box in your control panel. You can type in a question, comment, criticism, concern, sarcasm, snark. We take them all. If it is either entertaining or informative, we'll make it part of the conversation. I do have a bucket load of advanced questions. Hopefully we'll hit them all. If we miss any for any reason, then I'll make it a point to do it by email after the fact. And if you've got a microphone and you're not shy, you've got the little hand wavy icon up there on your control panel. Feel free to tap that. It'll light up something on my screen. I don't remember what. It's been a couple of weeks. And we'll bring you in and make you part of the conversation. So we're talking about the things that come after the transmitter. And of course, I'm a transmitter guy. So, you know, as far as I'm concerned, the world ends at that 3 1/8 flange. But apparently, a piece of pipe can be a conductor, an inductor, or a transmission line, depending on your frequency and all that great stuff. We'll talk about combiners, talk about maintenance, and what happens when it's not done. There may be pictures. Of course, there will be pictures. And on that note, I'm going to Gary Cavell. So Gary and Sean both sent me bucket loads of pictures. And guys, I want to thank you both very much for that, because you actually organized them in a way that I could understand, which is much better than when I look at my own pile. But absolutely, I appreciate that. Gary sent his in and they were organized. Like I get an email with a group of pictures organized by category. So I'm feeling pretty pampered here. And Gary, one of the things you were talking about was the different parts.
Exactly. And it's funny, you'd have to, I give a presentation to managers and owners for the NAB Leadership Foundation. And I have a petting zoo with actually pieces of transmission line and pictures. And they, if a guy comes up to you, your engineer comes up to you and say, oh, we got a bad bullet. It's not because you're in the hood. That's that little thingy on the inside of the conductor that connects one line to another. And just get it down to the basic level of knowing what the parts are and what to call them, not only for communication with other engineers, but with your part suppliers. But yeah, right. And all the guys on this call, everybody on this call knows what all these things are, but it's helpful to know how to explain them to your manager or to the owners when something goes wrong. Like, this is an elbow. What the hell's an elbow? Why do I need an elbow?
And over and above that, and one of the things that, and I'll be perfectly honest, it caught me not too long ago, and I should know better. But I was ordering up some hardline for a project, and elbows and flanges and all this great stuff. and I needed a 3 1/8 inch coupling, and I ordered a fixed flange, a solder flange instead of a field flange. So, little details like that are important for your planning project.
So we've all screwed up and ordered the wrong thing and had to kind of fake it till you make it. It's welcome to RF engineering. It's just you make it work.
Now, one of the other things you sent, and I'm going to get Sean to address this, even though it's your picture, you'll have to forgive me for that, but the 3 primary different types of coax that we use with big RF in AM and FM frequency anyway. And I mean, Sean, you want to talk to, what's your preference first? Hardline, hollow air core, solid core, each has its own purpose. How do you roll?
Yeah, it's really, that's determined by the application and the site and the local engineering staff. We see it all, and they all have advantages and disadvantages. When it comes to power handling, maintenance, how you're attaching it to the tower. Air flex line is obviously a very popular choice because it comes on a spool, and you just unspool it and then bring it up, prep the end, bring it up, and dress it on the way down and make the attachments. That's a much different installation process than doing a hardline run. And there's the connection, each connection in those flange viswars. When you have a 1,000-foot run, the stack up of the viswar, the flanges, can be an issue, or at least it needs to be a consideration. With the flex line, you don't have that problem.
And you have many more opportunities for something to go wrong with the more bits and more components. Each junction, each flange is a place where trouble can happen.
Yeah.
The other thing, Sean, is a lot of your antennas are pressurized.
Yes.
So the air dielectric line makes it a real handy way to pressurize the antenna, although I have seen people run copper pipe or hoses up a tower to pressurize the antenna separately.
Yeah, that's one of my rules in design, is that if there's an air volume, there's an opportunity for water intrusion.
Yep.
So when it's an unpressurized system, foam line is definitely a preference from my standpoint.
Mm-hmm. So Paul Meyer has asked, flicking back a slide, he'd never heard this term, and I had to be honest, I had never heard it either. Whiskey cup.
It's a specialized type of bullet. You saw it a lot in the old TV transmission lines. It's sort of an adapter. And so if you have a bad whiskey cup, it just means it's worn out from thermal flexing. And you go to the general manager, they need new whiskey cups, and they send you straight to hell and say, no, wait, it's one of these things. So.
All right, that's one of them situations where sometimes having the name like that could be a little bit of a challenge. But that was cool because, yeah, I don't think I'd ever encountered that one before. Side note for Sean, Laverne Siemens has thrown out, and for anybody listening, Sean and Gary don't get to see the questions. Ed and I see those. Oh, by the way, shout out to Mr. Disembodied Voice, Ed Sylvester, in the background, herding the cats and making us look good. But Ed, appreciate everything you do. Thank you very much.
Thank you, my friend.
All right, on that note, and by the way, Ed's a Bears fan, so everybody, give him a big sympathy smirk when you have a moment.
So sorry.
Us Packers fans do it on a regular basis. And Sean, I think you might root for the Patriots, if I'm not mistaken.
Yes.
Yeah. Gary, I don't know if you do football at all, so.
Well, I don't, because I'm a New Orleans Saints fan.
Oh. That's right. I forgot you're a Louisiana boy. All right. So moving forward, Laverne had asked the question about an antenna that's showing them some return loss. Coax connectors confirmed to be okay. Do you have a step-by-step procedure for riggers to be able to troubleshoot the issue? So if you've just jot a note, and I'll get you Laverne's contact info after. But there's the question: do you have troubleshooting procedures for a lot of this sort of stuff?
Well, again, if you've got, what type of antenna do you have? Do you have a side mount antenna that has a single feed? Do you have a panel antenna or an array of log periodics where you have lots of different feeds? That really dictates where you start. And indications. You start with the indications. What are the indications, and where are they pointing you? So there's the old troubleshooting terminology of Easter egging. You don't want to do that. You want a half split. So a good place to start is first get it, if you've got an antenna that has high viswar and you're not sure where that's at, do whatever you can on the ground to eliminate things like your internal transmission line components or passive devices like bandpass filters or whatnot, or even, there may be a transmitter problem. It's best to start there, figure out using dummy loads, or if you're lucky enough to have an analyzer and be able to use it, making measurements to ensure that the stuff that's easily accessible is okay. Once then you organize your crew to go do a visual inspection first. That sometimes is all you need. You go up and you go, oh, well, part of the antenna is missing. Very obvious and very quickly identify what the problem is. Then there's the ones that are intermittent, where you need to do a little bit more investigation. So I usually recommend breaking the line at the antenna input, verifying your transmission line is good, and then proceeding, depending on the antenna, into the antenna system.
I like to tell people to, well, all of us are busy. We don't have time to pay the amount of attention we could in the ancient days, but usually a transmission line or antenna problem will talk to you a little bit before it happens, unless it's a lightning strike or a tower rigger did something stupid. You may notice an increase in noise level, AM noise level. You may notice something changing in the transmitter fault system, slowly rising viswar indication. You might hear it. In ancient days of television, you'd actually see ghosting start to happen. So there's things, when did this happen? How long has it been going on? Was there a rainstorm? Was there a lightning storm? Was there hail? Are you near some place where guys think it's fun to try to shoot out tower lights and they hit the transmission line? So it's just go back through what's in the environment, what has changed, when was it noticed, where is the problem? Are you hearing it only on one side of town, or is it everywhere universally nuts, or it's only on the general manager's radio in the back of his toilet? I mean, it's when and where and what happened, what usually something causes it. So if you can try to do that kind of detective work, it helps point you in a direction before you start getting tower crews and analyzers and expensive consultants and all that stuff.
Yeah, it's also one of the times when having regular meter readings. And I mean, the cool thing about today's transmitters, like with ours as example, you go into the AUI, you can capture every reading in the transmitter. You can copy them into your clipboard, paste them into an Excel spreadsheet, do a different column for every day you do a recording, and then start to chart that stuff and plot it.
Guys track that to a weather application of some sort, so that every day they have like rain and the temperature, and they may notice something that tracks with rain or with the temperatures. That's a hint. That's something to go starting to look for.
So that's a cool idea. Now, in this specific situation, Sean, after we're done, I'll put you directly in touch with Laverne's contact info if you don't have it at hand, and make sure you guys get together and get it all looked after for him.
Great, thank you.
And on that note, let's move forward. So Gary sent me several pictures, and of course, like I said, we've got the different kinds of transmission line, whether it's your hard line or your air core or your foam core, but we never talked about the original transmission line, which is a bunch of wires with a ground.
Yep, and, open wire transmission line.
The nominal 600 ohm impedance, am I right?
Yeah, but the impedance can vary by the wire spacing and height above ground and all that stuff, but it's very efficient. And it's just amazingly, like almost no velocity factor. It's like 100%. It's really cool. The bad news is they're a high maintenance item, and I've seen, vines growing up in there. And also there's a bit of a mortality rate for birdies. If you get perched on the right spot and you're the shortest distance between the center wire and yourself, boom, see little feet hanging from the line sometimes where birds used to be.
Little puff of feathers, yep.
Yeah, but you see that a lot in very, very high power installations. Voice of America uses them, shortwave guys use them, some of the medium wave people. It really is inexpensive once you get past the first installation. A wire breaks, you replace it.
Yeah, no, I think the funniest one I ever saw was one, and of course you got them on the poles like this with the nice little spacers, and typically, especially in windy areas or areas prone to severe weather like we tend to get in the wintertime, you used to see there'd be little X-shaped spacers going down the line where you could put your grounds on the outside and it went over the center conductor or the hot wire. And the challenge, I ran into one site where those spacers were made out of plywood.
Oh,
And you want to know what their complaint was.
you see a lot of creative engineering in the field, and you can't really criticize it until you've walked in those boots. You know, sometimes you
Right.
do what's expedient, and then what's temporary is permanent. We've heard that before. So
I was making the running joke down the road in a couple of slides. We got pictures of different connection configurations for AM feeds, and one of your pictures. And what I was going to include was the vice grip connection, and didn't. But yeah, same situation. You run into a lot of sites where something got done, and then I'll get back to it and fix it. And then of course, there's always something else to do. I mean, right now, just outside this door, I've got a shelving unit that's got to go together so the Christmas stuff can come down, and so yep, it's an ongoing thing. Now, one of the other things, and this leads into some questions we've already been asked in the questions and in the advance, nitrogen versus air.
lots of opinions on that.
I know. I'm waiting to see what everybody says. So, Sean, you kind of you open your mouth and lean back, and I could see you gathering steam.
Yeah. Well, when you have, in the past, your choice was, do you want a compressor dehydrator or do you want a bottle of nitrogen? Today, you have the choice of getting something that's a nitrogen generator system. And I mean, that's kind of nice because bottles run out of air, especially if you have a continuous leak.
Mm-hmm.
But, nitrogen in itself being a dry gas it's dependent only on the gas itself to perform the drying, whereas a compressor dehydrator, there's more parts and more mechanisms that can fail. As far as I think when you're talking about nitrogen or dry gas and air, if you're looking at just the bottle type, then that, how do is your site accessible? Is it something where you have to bring a bottle up to the top of a mountain? Is your how many systems are you running? Do you have a manifold that's distributing that over to multiple feed systems? But I don't really have a preference myself, as long as it's pressurized and it's dry, and that comes down to maintenance. What's the maintenance schedule for the individual and for that site?
Couple of thoughts. If you've ever seen a nitrogen or oxygen bottle fall over and snap the lid off, that becomes a torpedo. So you have to handle these things carefully. And yes, please chain them to the wall if you're using a tank system. Nitrogen doesn't support combustion unless it's, like you're on the surface of the sun. So there's a lot of things to say nitrogen's a good idea. Some people are saying recently that nitrogen has some bad effects on the line, and I haven't vetted that. If you're using a pressurization system that's reliant on electricity, make sure that the thing works, make sure the compressor's in good repair, make sure I don't think you can put them on a UPS because it's not that critical, but at least find a way to get a pressure gauge, electronic sensing pressure gauge hooked into your remote control, your monitoring system to let you know that, hey, I'm in trouble. I think that's important. Couple of sides.
That's a big one. I mean, even here on my, I've got a jet pump on the well, and it's got a pressure switch on the tank to lock the pump off if it goes below 15 pounds, because at that point the well's probably dry and you don't want to burn up the pump motor.
Exactly. A couple other things is there's average power and there's peak power in the transmission line, and an old trick in the early days of television was you can increase, and you can still do it, increase the pressure of the gas in the line, and you can increase the voltage withstand rating up to a point. Surprising how many atmospheres of pressure you need to make a difference, but that's a trick. The other thing is using different gases. Old TV line, we would use Freon, basically. not to cool it, but just had a different voltage withstand ratio. There's also we used to use, I think it was, I can't remember the name of the chemical, but it was a freon-like substance. And if it burned in the presence of Teflon, then you'd make phosgene gas, and that was a bad thing. But but there's lots of tricks you can do for pressurizing line. But the main goal is to keep it at a higher pressure than the outside atmosphere. So if you do get a hole, it blows through the line and the air blows out. You don't allow stuff to be sucked in the line.
Mm-hmm.
There's also a ritual, which I won't go into here, on how when you first install a line that's pressurized, do you blow it all out? Do you super pressurize it? How do you get residual water out?
Yeah. And that's the other thing. You don't want to go too high in pressure, because then you end up blowing out gaskets and creating more problems than you solve.
Yep.
Another, just to add a little bit to this, when that pressurization is obviously important for keeping the moisture content out. But if you have a system that is at elevation and you lose pressurization, now you're really losing voltage handling. So, there are sometimes considerations though where you wouldn't want to design a transmission line that wouldn't work, wouldn't hold that voltage if it was not pressurized at elevation. That's important to keep those systems pressurized because of that. And just one more thing about what do you do if there is moisture? If you're using dry air is not going to get out standing water. You can draw a vacuum, which will vaporize the water, turn it into water vapor, and it can pull the moisture down through the vacuum pump. But be sure to disconnect the vacuum before you turn it off, because it'll suck the oil back up in. And that was actually, we've seen that happen. And the connection was all contaminated with the oil from the vacuum pump. So.
Yeah. Now, a couple other comments in the questions, and Matt and Joel both caught this. And I mean, I was semi-familiar about it from reading about diving, but nitrogen can be a suffocation hazard, and your body, because it's used to breathing a fair bit of nitrogen on a daily basis, doesn't give you any warning about nitrogen asphyxiation. So if you're purging or venting into a small room, you want to be super careful to have adequate ventilation.
Yep.
So Matt and Joel, thanks very much. For both of you hit that at almost exactly the same amount. And that's a really good point that I'm betting a lot of people don't think about. All right, moving forward. So after we figured out what kind of line we're going to use, then we've got to get it from the building to the tower. And again, different pictures, the wet picture, the dry picture, and the green picture, I'm going to call them.
Yeah, this was a triplexer AM site here in the DC area where we buried all the sample lines, all the transmission lines for 3 stations. And there's, direct burial cables, all well and good, but when you're digging the trench, you have to think about, am I hitting a bunch of rocks? Can I get rid of those rocks? Then how you treat the trench, because you don't want to be laying the cable down on where rocks are likely to come up from frost heaving. So you go below the frost line, you put sand and gravel in there, and then more sand, then you put your cable in and more sand, then you cover it up and try to keep bad things from happening. Because it's an AM site, I usually run the 4 to 6 inch strap down the trench with it. I like to run a yellow tape along the top of it. So some idiot's digging with a shovel, they say, hey, bury cable, you die if you do this. But burying transmission line I like because it helps for mischief prevention for the most part. Putting the lines over the ground, elevated on trestles, like those other 2 comments, pictures. That was commonly used in ancient times, but people will steal that stuff in a heartbeat.
Yeah, and green just screams copper.
Oh yeah, and you see in the lower one there's a strap, a flange, which is a homemade way of tying that line to the ground system. In AM systems where the wavelength is so long, an above ground line can start getting energy on it, and it can actually screw with the array stability. So we had a case in Pittsburgh, a now defunct system, was a 5-tower inline, God help me, where we found if we put ground straps periodically along the trestles, it would settle down the array, and the thing was much more stable than beforehand because there were lots of weird things happening. You could tell it was a problem because when you started to approach the line with the strap, you draw a 2 to 3 inch arc. So you say, maybe it needs to be grounded here. So
Yeah.
and you can actually see, the good news about above ground line is you can actually see where the visware problems are, because you see melted snow periodically at the half wavelengths.
Mm-hmm.
Anyway, all
And
kinds of war stories, but again, you can put it above ground, you can put it in conduit, which I prefer. You can do a direct burial. Managers are allergic to conduit because it costs money at installation, but it protects
yeah.
the line. So,
And the other thing with direct burial, and I'm looking at this picture going, yeah, you must be pretty far south because you're about 2 feet too high for burying line in this neck of the woods.
yeah, that
And
was Washington, D.C. suburb.
yeah, and the problem in our part of the world is we hit bedrock at about the point we get down below the frost line. So yeah, when they drilled my well, they hit, well, the frost line's 3.5 feet. Bedrock can be anywhere between surface level and 20 feet down, never much below that.
Woof.
So, and Sean, I think you guys have the same challenges down your neck of the woods. The geology's not a lot different.
No.
Now, let's see. What about buried in a conduit? Okay, you addressed that. Good. That came in on the side notes. What else am I missing?
Buried in conduit is the best way to go if you can afford it.
Yeah. One note: don't bury the lines in a landfill. They will settle and damage the line. And yeah, I mean, when you don't have a known substrate underneath you, it becomes a much, much bigger challenge.
An entertaining thing in landfills is if there's off gassing and you have sparky contactors, that can be exciting.
Yeah. Joel makes a good point here. There's a risk of putting coax in rigid metal conduit because water can get into the conduit, freeze, and crush the coax.
Bingo. You see that happening
So,
on transmission lines, on sample lines where you have them bonded, wrap locked to a tower, and water gets in there and freezes and compresses the line a little bit. Then the next time there's a rainstorm, it happens again. And eventually you have a gradual short developing. So it's one of those things, again, monitor your transmission lines, your antennas, your transmitters. Is anything changing gradually?
yeah.
Hard to do all of a sudden, but if you watch it every month, just take a quick look at the Nautel screens or whatever, is something changing?
Yep. And that's one of those things, like I said, even though there's no official in the rules requirement for regular meter readings anymore, it is a really good idea to do it on a schedule. Because, and I mean, the cool thing is now, because it's not in the rules, you can kind of pick the schedule yourself based on your own situation. But at least you'll have an idea if something's starting to drift or change, whether it's PDM filter caps going south and you're starting to see the noise level come up, or any bunch of, a whole bunch of things. So, all right, I'm going to flick ahead one more. And so, like I said, you two sent me a whole bunch of pictures. I kind of put them in at random as I hit, they caught my eye. And of course, I like shiny stuff and burny stuff with the best of them. So this collection from Sean got my attention. Sean, tell me a story.
Yeah, this is always a bad thing when you see this. But sometimes it's it's not an instantaneous. So these photographs are trying to show, if I had a video, you would be able to see this plasma flame, if you will, dance around with modulation. So how and why does this happen? This is a filter that was designed to handle 10 kilowatts with 20 kilowatts with a blower system. It was being used at 20 kilowatts without a blower system. And because the power head level that the transmitter with the TPO had gone up, but the equipment hadn't been updated to account for that. And there was some changes that occurred. And so what's happening here, the conditions of the environment were very high humidity. So this is in a very humid, high, warm place. The transmitter room was very hot, and transmitter rooms get dirty. Without that's just something that happens over time. And so the other thing that can cause this sort of thing is when a transmission system is very narrow band. So you're modulating across the channel and creating a difference in voltage across that channel. So this arc is self-sustained until you bring the transmitter down to a level where it extinguishes or shut the transmitter off. But what was really interesting is you could hear in the background with the video that I had, and I couldn't figure out a way to bring that to you, but you could hear the audio of the song it was playing, and it was Love Shack, baby, which is kind of interesting. There's not a lot of bass response with this kind of audio device, but so this is just a lesson in making sure the equipment that you have is sized properly for the power and voltages, currents that will be present.
Interesting thing is when this is happening, and Sean, you might have seen this, is a lot of the modern transmitters won't quench right away, or they'll just power reduce gently. The ancient transmitters would crowbar and you're done. So you can actually maintain an arc, and there's been a couple of burns in the past year or so where arcs were maintained by transmitters gently powering back and it still was sustained.
Yeah.
But
the other challenge is depending on the wavelength away from the transmitter output, the transmitter may not even see the impedance mismatch.
So use your ears. Are you hearing something funny in the audio of your station? That's one of the giveaways. The other thing is, tune either side of the station if you still can with the slide rule dial thing. Are you hearing cruzz that wasn't there before? Because this plasma is really great at generating a lot of intermod crap. So, there's a lot you can do just by your ears before you get out the fancy stuff to say, gee, something's not right, something's going on, maybe I need to drive out.
Yeah, and we had a situation once where third-party exciter driving a broadband transmitter into a narrow combiner, or narrow, tightly filtered channel combiner. So of course the filter is designed around figuring it's going to be filtering this much out of band energy. The exciter decided to broadcast on all the frequencies at the same time, including the carrier, so everything sounded good on the air. But there was now a massive amount of energy being dissipated in the filter, and it ended up arcing some Teflon and bad things happened. But again, similar situation, like you said, sometimes you have to look way beyond what oh, my combiner burned up. Let's swap the combiner. Maybe you want to figure out why the combiner burned up. And this is a good tie-in. Steve asked, they're talking about increasing HD carriers from -20 to -14. And is there a formula or a resource for computing power and peak voltage? And really that part is just math. Whether you're talking TPO or ERP, 20 dB is 1% of power.
It's in here.
There's a big book. Hey,
Yeah.
I think I know the guy that, I think I know the guy whose name's on that book. But anyway, yeah, I mean, 14 dB is 4%. So if you got a 100 kilowatt signal, 4% is 4 kilowatts. Peak power is 4 times that, 16 kilowatts. And then the instantaneous impedance at whatever part. And this is where you want to talk to somebody like Sean, because as you go through a branch combiner, for example, the impedance isn't 50 at every point through that combiner, correct, Sean?
That's right. And the fields are much more intense than in, say, a piece of transmission line. So that's why when you look at a filter and it's rated for 10, 15 kilowatts, it's got an 1 5/8 input, the cavity is much, much larger than that, just to handle the voltages present within the resonator,
Right.
and the currents as well. When you're looking at that's a great point. So if you're looking at average power, for FM, predominantly it's the average power that limits the how well the device is handling the thermal part of things. Peak voltage was not as much of a concern as it is in other broadcast bands, but with HD it started to become more of a concern, more of a design consideration, so it's really quite simple. If when you're looking at the DC peak voltage that something will withstand, then there's a series of calculations that you can do to convert that to what RF voltage it'll handle, and then through a consideration of its thermal characteristics, how much heat is it dissipating and at what rate. So those are all the design considerations that we look at. And when the filters are designed with enough headroom, most filters and antennas will accommodate HD. but it's always good to ask the question and make sure.
Right.
But the big
Well,
thing is, what kind of modulation are you using? In AM, you got to remember that you've got the modulation, which increases beyond the carrier level. And when you do digital on AM or digital on FM, you're putting more watts into the system. So if you're right at the hairy edge of the average power rating, you're going to want to talk to Sean or Jeff or somebody who's done this before. The good news is all these calculations, I held up the handbook because there's a discussion there, but it's simple math. It's not triple curl calculus and something horrible. You got a regular calculator. It's easily done, but get somebody to help you. I don't care how smart you are. I mean, when I'm doing one of these specs for a client, I'll call up Sean or Jeff or somebody that's smarter than me, say, okay, this is what I'm coming up with. What do you think? And no, you knucklehead, do. Oh, okay, fine.
well, and that's one of the discussions. I think I can't remember if I had it with you or with somebody else recently, but I was looking at an FCC approval for asymmetric sidebands. And of course, with asymmetry, I mean, with symmetric sidebands, we're allowing the 3 dB factor of having 2 equal sidebands. But when you throw in the asymmetry, that goes away and the numbers change. And of course, the FCC works in watts, not in dB. The manufacturers work in dB, not in watt. Well, we know the watts, but yeah, it's like you say, it's math, and you have to sit down and do it. And the big thing is when you think about the E squared over R, and for any given power level, if you got 100,000 watts and R is varying through a filter, E squared is going to have to vary in correlation to that. So you definitely, like I said, if you're in Steve, in your case, if you're upgrading HD injection, you're increasing it by a factor of 4, which on the peak voltage is a factor of 16. So if you're going through a channel combiner or any kind of filtering, that's significant, and you really should reach out to the manufacturer of that device for that. If you're looking at coax transmission line, that's a constant impedance throughout. That's easy to calculate. I can help you with that. Anybody can. So yeah, definitely, but reach out. We're happy to show you the math for it.
By the way, I have a boom story for you real quick. We have a hairy project up in Alaska we were helping with, a massive array system. We're talking gigawatts. And when there's a corona ball starting, there's a short, and this thing's starting to dance lightning around. The lower frequency modulation makes a reddish looking ball of plasma. The higher frequency makes kind of a bluish looking one, which is kind of cool until you realize, wait, this is a problem, we got to stop it. But it's neat to watch for a couple of minutes.
Yeah, and it's funny because Sean was talking about the plasma there singing, and I'm thinking, well, this is how you tell the AM guys from the FM guys, because the AM guys are used to hearing the equipment sing.
Sure.
You know, the coils in an ATU all the time. Yeah, absolutely. We don't even need fire to make it happen, although that does add to the entertainment value.
It's if you're hearing hissing, hissing is a bad thing. It's either a snake or the damn thing's got some plasma going on.
Yep. What's even better is when you see the blue ball jump out the front of the transmitter, float across the room, and disappear into the phone on the side of the wall as the phone disintegrates.
That's a Nautel add-on.
Yeah, it's not a bug, it's a feature. Now, Paul asked, and this is a question I don't know the answer to because I don't know what he's talking about, so I will throw this one to Sean because I know you do some tower stuff too. Wrap lock. He says that isn't great to use. Have seen it, but not much. Can cut into lines? I don't even know what wrap lock is.
I'm unfamiliar with that.
All right, Paul, you're going to have to explain what wrap lock is to us. But
it's like a fancy hose clamp.
Oh, there we go. See, you knew somebody would know.
Well, instead of having the serrations in the line, it's just another way of it's a metal band that you can tighten down like crazy. And if you get over anxious, it'll, cut into the line, and vibration and wind and stuff will also help it cut into the line and damage the line. So wrap lock was used a lot in ancient days. I don't know if it's used as much, but it's something you need to have inspected. If you can get a tower inspector to go up once a year just to make sure nothing's chafing or cutting into the line. But yeah, wrap lock is a common tool.
And I mean, that's one of those situations where, I'm not a big fan of using, and I've seen hose clamps holding down coax too. And I mean, it's not really that much more expensive to get the proper, U channel or round member adapters to hold on proper cable clamps.
It's all about the budget, pal.
Yeah, the butterfly clamps distribute that clamping pressure over a larger surface area. It allows the cable to slide a little bit through with some expansion. It's a much better option.
Yeah. And I say it's all about the budget. What do they say? We've got the budget to do it right, or we've got the budget to do it again.
And long lines, particularly rigid, if you don't use the right kind of hangers on the transmission line, you see these things with springs on it, the
Yeah.
line's going to move. And you might even have differential heating because you have the sun hitting some portions of the line and clouds blocking a mid portion of the line on a very tall tower. So you want to have the line properly hung and suspended. And there's even a ratio of how much line should go from the tower to the transmitter so it doesn't do weird things like push a transmitter over a couple inches when there's heating.
Yeah. Yeah. And Paul mentions tie wraps being used on small lines, and that's pretty common. Ideally, the black ones, so they don't disintegrate next year. But yeah, and those ones, I mean, less an issue with those. They're less inclined to cut into the line as you get more wind pressure or something goes sideways with them. They are going to break. So, you know, you're not going to destroy the line right away. After enough of them break and the line swings off and a good breeze comes by, well, then you'll have an issue. But hopefully you've had some warning and been to the site to do a physical inspection here and there. Again, you can't beat the hanger kits, but they do come with an impact on the bottom line. All right, moving forward. Let's see. I got a story in here. Sean, I can identify with your ability to hear audio in the transmission system. Keith, I'm going to ask you to just hit me a yes or no if you've got a microphone. By the way, folks, it's 1:45. As always, we are going to go over. We're having some fun here. I hope we're having some fun. If Gary and Sean, if you've got a commitment that you absolutely got to bail on me, let me know and we'll accommodate. But yeah, we're Keith. Let me know if you've got a microphone. I want to hear this story out loud. And flicking forward, this will kind of tie into that. So Gary, attachment methods. AM, I've seen everything from, well, I see the hose clamp for the ground on the first one. I see an actual really fancy looking clamp on the next one. You know, everything from hammer it flat to weld it in proper.
Yeah, it's the good news is that AM, the wavelength is, you know, roughly 1,000 feet long. You can get away with a lot of sins. One of my colleagues is John Keene, who works in FM and higher and microwaves, and he gets horrified by an OIB and the clip leads and the way we conduct ourselves around AM sites. It's great fun to harass him. But yeah, AM lines in particular, you can get away with, again, hammering the in flat, drilling a hole in it or punching a hole in it and connecting it with a bolt. Many of these lines here, you see they're just raw lines where you've made an accommodation. Other ones have a special in fitting in an EIA connector, like the ones in the lower right. That's for a 50 kilowatt systems, handle a lot of voltage. And then there's this thing where you see the number 2, the grungy looking photo. That's a 3-tower 50 kilowatt array phaser output.
Yeah.
Without any protection.
And the cool thing about those bowl insulators is that the purpose of the ceramic bowl is to give you a point to develop the potential between ground and center conductor, so it will tend to reduce your chance of corona.
Yep.
And the funniest thing about them is when they get dirty, like that one in the back, at that point you start to lose the dielectric principle of the ceramic and create a nice little, depending on how conductive your dust is, a nice little potential place to arc. So on this note, and this is a good time to segue into it, Ed's unmuted Keith's mic. So Keith, if you want to unmute yourself there and tell us what you were telling me in the comments there about the listening to the station.
Can you hear me?
You're good, loud and proud.
Okay, great. Yeah, I used to work in Pontiac, Michigan, and there was a station there, WPON. We used to call it Wampum. And you know, back in the day, I used to do the base current meter readings by hand. So I'd walk out there. It was a 3-tower array, and I used to walk out there, to, you know, with a clipboard and a piece of paper and copy down the base current readings. And you could easily, I could identify with what Sean was saying. You could easily identify what song was being played from the vibrations of the coils with the AM modulation in the phasing units. Yeah. And it was kind of funny.
Now statute of limitations is passed, so I'm going to throw an FCC note. Gary, weren't you supposed to be killing the modulation when you took your base current readings way back in the day?
Oh, you became quite expert at waiting till there was a pause. Noted then.
And the good thing is when you can hear the audio over the ATU, it's easier to do that.
Bingo. That's what we all did. Or, some people would actually not tell the truth, but that never happens in broadcasting sport.
Yeah,
Never.
what got a little scary is one time, or actually 2 or 3 times, I could hear, when there was a storm front coming in, I could hear
Mhm.
crackling at the top of the towers.
Yeah.
And across
Well,
guy wire insulators and in the tuning units, you can hear that. And that's when you really need to put down a clipboard, walk away.
yep,
Yeah.
it's time to be anywhere but right here, right now.
Well, I expedited things and got out of there.
Expedited is a good way of putting it. Thanks, Keith. I like those kind of stories. I'm glad I'm not the only one that's listened to that music more than once, and I suspect there are several others who have. Scott mentions a good point in the comments talking about Corona. And Scott, for what it's worth, maintains a couple of 50 kilowatt boxes, and so he's somewhat familiar with this, but no sharp edges.
Tower tops can be a sharp edge. I had another multiplex system where we're all proud, put it all together. It was a couple of 50 kilowatters and some other thing. And we started to have Corona off the top of the towers. And, first I'm seeing these blue flames and I'm hearing the radio outside. What's up? And these guys are doing their job. So we had to put Corona balls on sticks on top of the towers, which I'll try to send you a picture sometime, Jeff, so you can share it afterwards. But something to distribute the charge so it doesn't flare. A lot of other guys have used stainless steel salad bowls from restaurants to bolt on the tower top to to distribute the charge. It looks goofy, but it saves your bacon because the Corona is a bad thing. It'll erode the metal, but also will generate a lot of intermod and harmonics, and the FCC gets allergic to that.
Yeah, they get a little cranky, especially depending on where it happens to land in the band. But the other thing you'll notice, like if you look in a high power combiner, when I say high power, I mean we've done them up to 2 megawatts. And a 2 megawatt combiner, all these like ceramic insulators on this top right picture with the bolts in the top, all those bolts would be hemispherical and perfectly round, and they're tightened with something that looks like a glorified oil filter wrench.
Yep.
Because yeah, or they just pop on to cover the regular hex nut, either way. But the goal is, again, not to have an exposed sharp edge.
That's why threaded connections inside ceramic insulators can sometimes cause trouble because the sharp edges will start Corona and it'll crack the insulators.
Yeah. Chris mentions in the comments he once heard 6 ball gaps snap in stereo, and that was his cue to get out of there.
Run like hell.
I maybe paraphrased just a little bit, but yeah, you got a lot closer to it. And so then we've got the plumber's method of RF work. And there's a reason why they call this stuff plumbing.
Oh God. Yeah, you just kind of ram a copper pipe into the center conductor as best you can, get a good physical connection, and then flatten the end with a vice grips and put in a strap and you're done. It's like, God. And that thing operated like that for like 10 years, a temporary fix.
Yeah, and Scott mentions too that wiping down I was talking before about the bowl insulators, and when they get dirty, you lose the dielectric principle of the ceramic, and yeah, wipe down the base insulator with alcohol because the dirty insulator is a failing insulator. And the same is true for guy wire insulators. When Keith was talking about hearing them start to snap, I mean, once a guy wire insulator arcs, it develops a carbon track, and at that point, after a couple of times, it's no longer an insulator, it's a conductor waiting for a chance to happen.
I got an exhibit E in my office. I show people, hey, this is a faulted insulator from a carbon track.
Yep. Yep. Now, moving on back into the FM realm, Sean sent me this picture, and I realize this is laying on the ground, but it was a really cool picture. And it's like, I've got a photograph of and Sean, you'll have to help me. I don't know what I've got for an antenna up there. I think a 6814, a 2-bay rototiller style, little bitty low power jobby, covered with, well, I've got a picture of it covered with about 2 inches of radial ice, but it wasn't horizontal at the time.
Right, right. So this is just to show, an extreme icing condition during tests to find out, this is one of the things that we do with our testing is to determine just what the antenna performance is with that. Generally, what's happening there is once the ice forms on the radiating arm, it increases the diameter of the arm and changes the frequency, because that's part of the formula for a dipole, resonant frequency of dipole. And the other part is to see how the icing affects the current mode of the dipole at the feed point. As far as shifting the frequency, almost all of that happens. You could ice the feed system in this antenna where the white cap is. You can encase that with ice entirely and knock all the ice off the ends of the arms, probably the last 30% of the arm, and bring the antennas almost back to the original performance. But that's not looking at the current handling of the feed point at that point. So, you know, this is kind of it is an extreme version. And what we were doing here is back in the days where we were cross-feeding combiners and feeding the digital into the left-hand circularly polarized feed of a panel antenna. So you could feed the analog into the right-hand circularly polarized side and the digital into the left. We were seeing how the icing affected the analog to digital isolation to ensure that maintained a value that was usable under these kinds of conditions.
Mark Persons makes a good comment in here, and Matt Golston referred to it as well about Matt mentions getting a brass screw rather than zinc, and Mark clarifies by telling us avoid using metal hardware that can be attracted by a magnet, i.e. ferrous, because it can vibrate at the frequency operation and melt under some conditions. And of course, we all know, especially with high power AM, we tend to use brass hardware or in some cases copper, depending on what we're doing. But that's the principle, is non-ferrous material.
Does Sean have any thoughts on the age-old question, chicken, egg, radome, de-icers? I know I just prefer radome myself because it's hard to break and always works.
But
also adds a lot of wind load.
So and there's your consideration right there. It's always comes down to that.
And weight. I mean, I've got a situation, and I'll pick my particular station as an example. Our tower, by current standards, is already running at about 110%. So we're not going to add radomes or icers because the extra cable or the radomes themselves would put it well beyond what we're comfortable with. So yeah, it does, you know, but the other thing I've run into when you get this far up, the de-icers, they tell you basically that you're supposed to turn them on anytime there's a chance of ice. And for our here, that starts in October and ends in May. You know, there might be 2 days where it's turned off in between.
Well, so, what we've seen, and one of the reasons we recommend that is it's amazing how much heat gets dissipated in cold weather with a slight breeze. You can have a arm, you know, a radiating element that has a de-icer in it that is inside an ambient temperature, is running at 300 degrees, and you stick it outside in 15-degree temperature or 0-degree temperature with a 10-mile-an-hour wind, and it's going to be barely above freezing. So what that recommendation is to allow to prevent the formation of ice, because if the ice is already formed, as in extreme example of what's you see on the picture on the right, you may just end up melting a hole out of the ice, and the ice is still clinging to the antenna.
Right.
It's still causing issues.
So, I understand the reasoning behind it, but look at your local geography. Like if I was inland further with drier air, then I might be a little more inclined to go with the de-icers over the radomes. So here on the coast, you know, if I had the option and the antenna or the tower to handle it, I think I'd lean toward the radomes too. But
yeah.
But again, situational, the same old, same old. And let's see. Radomes are great, but I've had enough icing on my antenna with radomes that my transmitter will still back down to under 4 kilowatts. Your antenna, my transmitter, but we didn't need to name them. Anyway, it doesn't matter. Yeah, that can still happen because the radomes, basically you're creating a shield if you cover it with like wet ice, like freezing rain, right?
Radomes often have a drain hole on the bottom, but if they're installed wrong, you end up with an aquarium. And I've seen it happen more than once.
Yep, true too. So there's something, Joel, just to take a look at as well. Yeah, and Matt mentioned the same thing, had radomes fill up with water because of a hurricane, in which case, you know, the hole could be on the bottom, but the wind's blowing the rain that way too. So very cool. Then back to the Bernie bits. Gary, you sent me these ones because nothing is ever proper until we cooked it.
Yeah, two interesting pictures. The one on the right is actually a transition from, I forgot what, 7/8 inch to 1 5/8 inch, whatever.
Yeah.
And the fitting underneath that cone looking thing on the right-hand picture actually kind of caught fire, and you could see where the smoke and the contaminants went up through the connector and into that center conductor off that elbow, and pretty much made a mess of that line. The thing that it was connected to is on the left, which I think brass burns or melts at 1200 degrees. So there you go. And yeah, and you notice that on the left-hand side of the connector, there is like no insulation on the coax. Yeah, that was actually it was a combined situation where the detuning or the filtering for the undesired frequency wasn't robust enough. And that connector was at like 90 degrees exactly when you figured velocity factor, right at the wrong part. So you had just enough voltage coming back and at the high voltage point, and it melted down. So make the filter better and put in a bigger line transition and try to move where the high voltage was. But yeah, that's a lot of dancing here for a very complicated situation that was totally unexpected because it should have handled it, but it didn't. It was just really exciting when smoke in the transmitter room is like, holy shit, you know, which is a technical term, Jeff.
Yes, it is. We had a situation similar out on the left coast where I got called because transmitter's shutting back, and we got looking and it's like, okay, it's not seeing SWR, it sounds like filter current. And got him to pull the cover off the filter, and he says, there's black soot. And I said, okay, that's bad. So we get him a new filter, and it's two transmitters combined. And while this one's down and the other one's on air and the filter's on the way to him, the other one starts to arc. And I said, back the power down until it doesn't arc and leave it on the air. And it looks like I'm buying a plane ticket. Well, we get out there, and what we discovered, I found the piece of Teflon and checked with engineering, and they go, oh, we probably should have made that a little thicker. So they resized that, and we got that rebuilt. And then they said, but it would have needed to see a high voltage. So I grabbed a tape measure and walked 90 degrees back the coax and ended exactly at the input to the branch combiner, and pulled the connector, the 3 1/8 off, and a pile of soot comes out. And I say, aha. Like I said, sometimes you can't just solve the problem. You got to figure out why it happened. Now, speaking of that, Sean, whoops, I got a little carried away. So you sent this one, and I'm assuming they're all the same antenna, but there's something appears to be missing here.
Yeah. Well, what we're looking at here is, you know, and there was another photograph that showed a cracked flange. And this is something that happens on towers that have excessive movement, or if things aren't tied down well. But sometimes the failure is starting at installation. And if you can see, it's not quite clear, but the picture in the center is trying to show that the flange is now bent and not straight. It's not manufactured with an angle on the flange. And so it somehow, it looks to me like this bottom section it looks like a taper in the photograph, but I think what happened here is the mount was used in the wrong location in the array. This mount that's attached to it. So in order to make it fit, not everybody looks at this as a problem and looks at this as a challenge, I
It's
think I can
spaced
make
off
this
2
fit.
inches. We'll just tighten it down a little more.
With enough come-alongs, I can make this fit. And that's just an example of one of the ways that a flange can fail, even without tower movement. If there's any fit issues, it's best to have that remedied ahead of time, because it's just going to create problems and stress on the connections. They're incredibly resilient, but they can't withstand it.
It will break eventually. Now, here's a question for you. Do you climb?
A bit. I haven't in years now.
The challenge with getting less young is that those things take a lot more work than they used to.
You get smarter.
Yeah, that might be it. You discover that you don't bounce near like you used to. I break now instead of bouncing, so I try to avoid that. But now, having said that, I know guys that are climbing well into their 70s, so there are some out there.
Nothing but respect.
In the advanced questions, somebody had asked, is there any good routine maintenance type thing that you can do to sort of detect stuff like this, or to detect any kind of situation, both maintenance and I guess not really troubleshooting, but just like we talked before about regular meter readings. Is there anything else that people should be doing on an ongoing, whether it's annual, monthly, whatever basis, to look after their antenna system?
I think just look at it. Just, stand on the ground with a pair of binoculars and just go up the tower looking at the line. Just look and listen. You can sometimes hear a problem. Sean, I interrupted you. Go ahead.
No, I was going to speak to FM installations, but that idea of monitoring the indications, it's never too late to establish a baseline of the operating parameters of a system. The best time is during installation, so you have right out of the box manufactured, approved installation parameters, and that's your benchmark. Anything different from that is going to be either an indication of just normal swings in the performance, or an indication of something going bad. But it's a great way to establish a comparative measurement that you can look at over time. So that, I can't stress that enough. That is, and Gary has mentioned this several times in this discussion. Probably one of the most important things is indications. What gives you a clue that there's a problem to begin with? And in these days where station engineers are managing so many different sites, remote control, remote monitoring, that's how you get it done. But taking that time to just check, especially after an event, a weather event or something like that. So the other thing, Gary, you mentioned doing a visual inspection. If there's some indication that something's going bad, thermal imaging is a lot more easy to access today. And that's a great tool to find sometimes those burned up connections start because of loose connections and not excessive. Well, that could be causing excessive voltage in another part, a quarter wavelength away. There you go, right there. That device right there is worth every penny you spent on it.
And
we looked it up.
We do a ton of that, and a lot of them are drone mounted. But even with a camera like Jeff showed that you can put on the bottom of your iPhone or your Samsung phone, you can sort of scan the tower, preferably at night when the sun loading, thermal mass loading has gone down. Is anything looking at a different temperature? And look at it from different angles, because sometimes it's just wind blowing. But do you see it that way? When you have a tower guy on site, have this guy go up with even a little thermal gun, because your skin can't really determine. It has to be a big temperature difference for your hands to really pick up temperature extremes. But a thermal gun or a camera like Jeff just put up, just take pictures as they go up until they have to turn the thing off. But just look for thermal differences. Thermal means loose, means something's wrong, something's going to burn up. You can also use a consumer drone and go up the tower and just look at stuff. Caution, RF, and particularly microwave RF, can make drones lose their mind and they'll go away, they'll crash. But don't ask me how I know. But there's a lot of tools available to you. The other thing is if you have access to a vector network analyzer, which is a very scary thought, but there's a nano VNA out there, a little $50 thing. And if you get brave one night, learn how to run it and see if you can't hook it up to your transmission line. Just see what you see and take a picture of it. If there's somebody else radiating on your tower, that would be bad news for the VNA. But turn the power off, scan the line, see what you see. And you can sometimes see all sorts of exciting things and just, okay, here's a picture today. A year later, you do it again. That's another tool, but not everybody has the time available or the money to do this. But there's lots of ways of looking at it, but your eyeballs, your sense, your monitoring, listening, and use the tower climbers. Tell them, hey guys, you got to look.
And by all means, if you go back through the archives of the TTT sessions last, I want to say November, I think, we had Dan on from Alabama, and one of the things he mentioned was the micro VNA. So there is a link to a source in that Gizmos and Gadgets, I think was what we called it, webinar session. We're running past even the late time that I usually shut down, so we're going to high speed a little bit. Some of this stuff we're coming up to we've already covered anyway, but this is a good one. And one of the advanced questions was a recommendation for a coax switch, and my short answer is whichever one fits in your budget. You can go, the MCR ones are cost effective, dielectric is the higher end, Mayat fits somewhere in the middle. Switch controllers, they all make switch controllers. Steve Tunwall still makes a great switch controller. Or you can do a simple manual patch bay like this. So Gary, what are your thoughts on this? You sent these pictures, so I'll let you talk to them.
Well, again, it's about budget. The thing in the right-hand side is electric. You can pulse it with a remote control and switch things remotely. If you have one that's manual or it isn't hooked up to a motor, then something goes wrong. You have to physically visit the site and make it all better. You see this in television, you see it in AM, you see it in FM. I mean, so the switches are out there, they're garden variety. You just have to size them appropriately and make sure you take a look at them with your little thermal camera on your phone. Is there something a little bit warm there? The thing on the lower left was something that was, we have dual transmission lines going to each tower in this particular AM installation. And if something goes wrong, you just take out your screwdriver and the rubber hammer and you whack the patch bay off and move it over and whack it back on and tighten it down. So 3 different transmission lines with a A and B option there. So that's lots of options. Patch bays are cheap, relatively speaking. Nothing's cheap in broadcast, but a patch bay is less muss and fuss than, but again, you got to be there. A motorized switch is living right. That helps you.
Yeah. And I mean, for what it's worth, depending on your power level and the size, you can get a coax switch for down, well, if you're dealing with N connectors or B and C connectors, you can get them down into the hundreds of dollars, but even a couple of grand for a 1 5/8 or a 7/8 coax switch with a controller, figure 3 grand for the low end, what, 10 grand for the top end at a ballpark guess?
I would guess, yeah. And of course, with AM, you can get away with a contactor and some nasty open air connections and real ugly, and it works fine.
Yeah, or as I've seen in more than one site, one of the old-fashioned electrical knife switches.
Oh yeah, works good, lasts a long time.
Yep. And it's cheap to replace if you ever burn it up or forget to shut things down before you make the switch. Now we were talking thermal imaging, and somebody sent me this one, and this was a perfect example of using a thermal camera to find a potential issue.
Yeah, that was in the region, and the guy was complaining of some intermittent funny sounds, and the transmitter meter was fluctuating, and so we took a look at everything inside, went outside with a thermal camera, said, red is good, blue and black is good, orange and yellow is bad. And we took it apart and got about a gallon worth of soot out of it. And you see the inner there at the elbow, and you see all the carbon and crap all over. So yeah, that was replaced, and you had to clean out the line in the vicinity of it because the stuff, like a chimney, will travel up the line. And good as new. But again, if you have access to a thermal device, thermal camera, you can see differences. The thing is, how much difference is important? 5 degrees, 10 degrees, I'm not too worried about. Right. 20 degrees, particularly in RF system and combiners, starts to get me concerned. Anything, and Sean, you probably have some indicia for your stuff, but anything more than that, 400 degrees, oh hell, do something. Sean, do you have a thermal scanning recommendation? How many degrees is maybe too many?
Let's see, with the RF filters, the current in these can be, at the grounded side of the resonator, can be several hundred amps. So there's a lot of heat dissipation. And in general, again, it comes down to the baseline. And if you're not sure, contact us and we can tell you if it's normal or not. Because normal operating temperatures on some filters on the semiconductor, on the center cavity, is 120 degrees Fahrenheit. But if it's normally 120 degrees and that's a benchmark that you've established, and then something isn't quite right, the visual is going up and now it's 140 degrees, so a 20-degree delta, that's an indication that something has changed significantly enough to look at.
And that is a huge point, is establish your benchmark. What's normal? And then go back, a month or two later and scan things again. Is it different? And if something changes, and while you're there with your thermal camera, look at your electrical panel, look at your breakers. Is there anything, what's normal for that?
And beyond that, it's critical too, if you're using one of these guys, the little thermal imaging cameras, take note of your contrast settings, because I can make that deviation represent 10 degrees, or I can make it represent 100 degrees, depending on how I set the contrast in the software on the camera.
That's a whole other seminar on how to do thermal imaging.
Right, so record your measuring settings, your measuring device settings, as well as what you're actually measuring, because that way you will be able to repeat your benchmark, because an experiment you can't repeat is not really an experiment. But that brought one good note. You commented earlier, and I see on the timestamp 12:39 a.m. that you were following your own advice about doing this stuff after sunset.
Yep.
So very cool. And Sean, you had mentioned the broken flange. There it is.
Yep. And that was that's when we get things like this back, we do a engineering analysis of it to determine exactly why it failed, whether it's material problems or whether a bad batch of brass, or if it's if there's a design issue, or was it just in a situation that was not a realistic expectation for the physical strength of the design to withstand. In this case, it was the material. It was a bad piece of material, and that's one of those things that you have to support. So, and we did.
But
so
same deal, yeah. Sometimes you have to do some investigation.
When the follower is over that, you can't see it. There's no, you have to bubble. You have to do some bubble spray to find things like that.
Yeah. Matt makes a good point too, that if you are cracking a line open in the process of troubleshooting something, to be pretty careful about it, because they can be full of really hot water or almost steam, depending on the situation that's been going on at the time. And you can end up burning yourself if you're not careful.
Yeah, good advice.
So, and that comes back to like Gary was saying earlier with the vacuum, where you shut the vacuum, or you pull the connection before you shut the vacuum off. And in this one, if you've got a way to vent the line before you disconnect it, it's probably a good idea to do that. You're going to lose pressure when you disconnect it anyway, so there's no point in not doing that in a more controlled manner. One other thing that we got asked about in the advanced questions was a little bit of talk about filter theory, and Sean will recognize this picture because it's this amazes me, because this is the freaking magic part of FM to me. Just how the fields expand and collapse as you go through a filter. So Sean, just give me a little brief 30-second rundown on this as I click through.
Okay. So this is there's been a lot of talk about computer simulation, computer modeling. Oh, that's a nice picture.
We'll get to that too.
But what it allows you to do is visualize the fields. And in that video, what you're seeing is the magnetic field expand and contract. The electric field is parallel to that. So what you're seeing is the vector values of the magnetic field as it cycles through a wavelength or a cycle.
Mhm.
And
And I mean, this is sort of a side, and I'm skipping off filters to another topic because again, we're running show. I'm going to have to get both you guys back for a sequel in March or April if you're free. Depending on what happens with trade shows, that may be very possible. But there's been some talk recently, and you mentioned it here, so I wanted to bring it up while it's still in my mind because things go in and come out almost immediately. Computer modeling. There's been a lot of talk about computer modeling, and you've done a fair bit of it over the years.
yeah, we started using a product HFSS to use to do 3D modeling, electromagnetic models, and you know, that's the thing about this is that now you used to take information from a textbook, you'd come up with an application, a design need, go to the textbooks, come up with a design from the formulas that are available for that, make a prototype, and then you'd say, all right, we got really close, but the textbook formulas are not complete for this type of arrangement. And so you'd either have to come up with a variation of that to produce a more accurate prototype, or you'd send it to the lab and have the technicians work their magic of making, as somebody had put, technicians make engineers' dreams happen. So you know, that was the process. But today, so you can build something if it's modeled properly, you can build something in a virtual environment and prototype it through there. And you know, by being able to visualize the magnitude and location of where the fields are most intense, you can optimize the design towards that. And this is the top view of a 3-pole filter, and you're looking at the first 2 probes. So as you can see, the energy, if you can think of it in time, it enters the filter at the input and exits the filter at the output, but what's happening in between? And what you see here is the field expanding and contracting in the first cavity, which then couples through an aperture in the middle where you see those tangential lines there. And you can't quite see that aperture, but it's there. And then it couples the energy into the other cavity. So it's a great way to visualize the electromagnetic fields.
Yeah. And so that takes us to 20 minutes past the top of the hour, which is way late, but when have I ever finished these? Well, I think we did one on time, maybe 2 in the entire 58 episode history of these. It'd be a shame. Now, one other note, and I think Sean sent me this picture, but I know that we all have pictures like this. Clean up, pick up the mess, folks. You know, right off the bat, if you're leaning in to do a punch down on the phone wall there or get something off the bench and you step on that chunk of coax, you just became a casualty, or that chunk of hardline rather. But Gary, I know you've seen sites like this, and I looked at that picture and I said, holy smokes, I've been to that site. Well, maybe not that site, but one almost identical.
Yeah. It's definitely the challenge today is finding the time to do things like this. You know, it's just one of those things where you're just getting the thing going sometimes and getting out of there to the next problem. But this is definitely something that if you've got any time, or a new guy that needs to do that initial grunt work, earn their stripes.
Paying the dues, man. Paying the dues.
I use it as an opportunity to, if I'm visiting firemen and trying to deal with a site, sometimes you just need some time to think. So since I don't smoke a pipe anymore, I just need to do something. So I just start neatening things up and hopefully not cheesing off the local person. But and it makes it better at the end. And I have had a local engineer here say, "Why are you cleaning things up? It doesn't matter." I said, "Well, it matters to me." So, and also makes it safer so you don't fall on something or hurt yourself. So, when I'm at a site, you might see me, putting things in corners and taking out a broom, but I'm thinking I'm on the clock. But just sites like this drive me crazy because it's
so I used
fire hazard.
used to work a lot with Don Jones, our specialties down in Amarillo, Texas. Don's still kicking around. So Don, if you happen to catch this on the archive, I was thinking about you, boss. But Don wouldn't leave a site until he'd mopped the floor. And I mean, I've seen him mopping some pretty questionable sites here and there, but that was just his little routine. Yeah, leave it cleaner than you found it.
Yep.
And you know, it's a good philosophy overall. And it might just be, my wife has done disaster restoration in a past career, and one of the things she says, we'll hit something, and I go, it's not as good as I could have got it, and she goes, it's better than it was. And you know, if you keep going to better than it was, you can get pretty darn good pretty darn quick. All right, on that note, we are way past the top of the hour, folks. 180 has stuck with us all the way through. I thank you very, very much for that. This webinar, as with all of our webinars, will be archived. And so by all means, you can go to resources tab on our website and click webinars and find your way through to this one. Waves newsletter links to a lot of useful information, YouTube channel for this stuff and customer service tech tips. Online info, I've got Barry Michigan's BDR desktop or .net. Barry does a weekly Thursday lunch session, lunch Pacific time, I think. Well, it's 3 o'clock my time, so I guess it'd be a little before lunch Pacific. Anyway, in that time zone, there's, you know, Facebook groups, broadcastengineering.info, tons of great sites out there. Paul asks in the comments, if you're by yourself and crack your skull, does anybody hear? Your next of kin might. So highly recommended that yeah, and Paul makes a comment that if the fire inspector shows and the site's clean, they tend to look and leave a whole lot faster than if it's a proper mess. And you might find something you could put in stock for another problem down the road, and that has happened. So little side note, non-related to any of this, and of course I already said all the closing stuff, so we can tell the story and goodbye. But it snows up here, as you may have guessed. We were talking about it before we opened this mics earlier, and I have a snowblower because I'm getting old and lazy. And that's all wonderful until I run over a rock in this lightest snowfall and broke a shear pin. Because I walk the walk that I talk, I know I have spares. And those spares involve extra shear pins, which I saw in June somewhere. And I said, it'd be really cool if I put those together with the wrenches I need to change them, and then I'd have them right where I need them when it's time to replace a shear pin in the snowblower. Don't ask me where that somewhere was. I still don't know. So at that point, the backup systems came into play, and the boy and I got to shovel the driveway. But not recommended, not once you pass 50 something. But anyway, you know, again, backup systems are only as good as the last time you tested them, and spares are only as good as your ability to find them. All right, closing comments. Sean Edwards, anything from you before we head out?
I just wanted to, you know, there's so much that we wanted to talk about. We did talk about an awful lot, but I did want to share our resources that are available on the website. So if you go to www.shively.com, there's a tab for resources, and there's several white papers in there, most of which have been written by Bob Surratt, so you get a little bit of flavor of Bob in those. But you know, that's a great, there's a lot of the topics that we talked about and a lot of others are available there. So please go check that out, and you'll find some light reading there.
Ed, if you're still with us, and I mean, I know we're keeping Ed up way past lunchtime, but if you could jump into the chat and just throw in a link for that while we get Gary's closing events. By the way, Gary Cavell, fccinfo.com. I live and die by that site. Don't ever drop it.
Thank you.
Great site.
All right.
My thoughts are that no off-air event or transmitter failure is worth hurting yourself or losing your life. We're not in medicine. We're not saving people's lives. Well, we are if there's an emergency, but take your time. Don't go to a site tired. Don't work alone if at all possible, and just go slow. Look at things, gather your thoughts, There's lots of people in the industry that will help you by phone or text or YouTube or whatever. You can reach a whole bunch of experts almost 24 hours a day. So don't panic. Something happens, just take your time and reach out to resources. And if you have an ununderstanding manager or owner, then maybe you want to think about someplace else down the road when you can. But don't get yourself hurt. Just take it slow, take it thoughtfully, take notes. That's my advice. It's just there's no need to rush, no need to compromise safety.
And sometimes the deep breath, as you said with the cleaning, sometimes that deep breath is what you needed to clear your head and help you get through what was actually going on to begin with.
Yeah.
On that note, I want to throw a huge thank you to Sean, to you, and to Gary both for giving me a whole hour and a half. Well, would you count the preamble, closer to 2 hours of your day. I know you're both busy, and I really appreciate it. Thank you.
My pleasure.
And definitely, again, folks paying attention, whether it's live or archived, thank you very much for being with us. Next week, we're going to talk a little bit about networking and taking the last week off. I was supposed to be on the road. That trip got canceled, but I'm still taking a break. Sue me. However, February, I had to remember what month it was going to be. February is going to be networking month. The big challenge I've run into is twofold. Number one, we've got a lot of us less young people who got dragged into IT kicking and screaming, and we've learned what we needed to learn to do it, but not necessarily always well. And if you look at my home network, that'd be a prime example of that. So I'm going to bring in some younger, smarter people to talk about that. Hopefully some of the younger, smarter people in the audience who know more about this will chime in and help out as well. But we got 3 or 4 sessions. It'll be a lot of fun. Gary and Sean, as I said, I'm going to try and bring you guys back March or August or April, because there's a lot more that we could have covered and just totally didn't have time. So on that note, thank you all for joining us, and we hope to see you next week. Bye now.